Hello everyone, good morning. I hope I'm audible.
Yes, you are, ma'am.
So, dear authors and invited guests, welcome to the technical session 4D. So, I am Meghna Mathur, and this session would be moderated by me. And on behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any queries or any update, you can write me in the chat box. So just before we start the session, I would like to introduce you to the session chair, Sir Dr. Pankaj Chandra. He is a professor in MIT, ADT University, Pune, India. Dr. Pankaj Chandra is an associate professor in the Department of Computer Science and Engineering, MIT School of Computing in Pune, India, specializing in areas like machine learning, network security, and AI, with numerous publications and a significant count on Google Scholar, actively contributing to research in computer science and artificial intelligence. Sir, welcome.
Thank you so much, madam, for your nice introduction. Yeah, thank you.
So, if you would like to
So, can
address
we
our
start?
yes. So now starting with the
Yeah,
conference.
at last I will address. At last I will address.
Okay, sure, sir. Thank you. So now we start with our presentations. Our first paper is being presented by author Prasanna Lohe DS Adme. He is from Ramdobia University, India. The title of the paper is A Comprehensive Analysis of Predictive Machine Learning Techniques for Predicting Relapses in Childhood Nephrotic Syndrome. So please, Prasanna has not joined. Okay, we'll move further. The next paper title is being presented by authors B.S. Sindhu, Kanipis Rivali, Paleti Jeevan Prasad, Manisha Kumari. They are from Godavari Global University, India. The title of their paper is A Privacy Focused Face Recognition System with Cancelable Biometrics.
Good morning, ma'am. Hello, good morning, ma'am.
Who is from your side? Shivalli madam.
Hello, sir.
Actually, echo is from your side.
Dear presenter, you may please rejoin this meeting. Maybe audio issue solved that time.
Meghna madam, is it okay from?
No, actually, I am also hearing the echo from the presenter's side. Ma'am, could you please rejoin the call?
No. From my side, is it okay?
Yes, sir.
Oh.
So now, Meghna, we can call our first presenter. I think Prasanna is in meeting. So please call
Okay.
Prasanna for presentation.
Sure. We have our author, Prasanna Lohe, and the paper title of this paper is A Comprehensive Analysis of Predictive Machine Learning Techniques for Predicting Relapses in Childhood Nephrotic Syndrome.
Dear presenter, you may please start your presentation.
Hello, am I audible?
Yes, you are.
Yeah, just 2 minutes.
Sure.
Am I audible?
Hello. Yes, sir, you are audible. Please start your presentation.
Yes, my contents are visible.
Sir, play slideshow. Yeah, it's visible now.
Yes, slides are changing now.
Yes, sir. Yes. Please continue.
Okay, yeah. Okay, so very good morning to one and all. My paper title is Machine Learning Based Relapse Predictions of Childhood Nephrotic Syndrome. And my paper ID is 601. And my name is Prasanna Lohe from Ramdev Baba University, Nagpur. So the contents of my presentations are abstract, problem definition, introduction, then literature survey, then proposed methodology, conclusion, and references. So the abstract is the pediatric nephrotic syndrome is well-known kidney disease and having the relapses that causes the significant morbidity. The regular relapse prediction methods are dependent on some clinical and biomarkers variables, which is having the lack of accuracy for the further treatments. So using machine learning approaches in this field may generate the long-term outcomes So till date, the surveys focus on the adult disease or the general kidney disease. So in this paper, we are offering the thorough analysis of the machine learning algorithms and its techniques with clinical integrations and interpretability. Obviously, this fills the gaps between the traditional and novel techniques. It also highlights the difficulties observed by the pediatric practitioners using multimodal data and practical deployment issues. Here are also suggesting the innovative framework that combines the sequence modeling and related learning. So this framework also provides the flexible and morally sound solutions for the future research. What basically the problem definition is, the problem definition is machine learning based relapse prediction in childhood nephrotic syndrome. This study established a machine learning based prediction model to identify the relapse of childhood nephrotic syndrome. What exactly the childhood nephrotic syndrome is? Basically, the nephrotic syndrome is a group of symptoms that indicates the kidney are not working properly. So these symptoms includes too much protein in the urine, and we called it as a proteinuria. Low level of the protein called albumin in the blood called hypoalbuminemia, and the swelling in the parts of the body called edema. So nephrotic syndrome is a rare and a serious disease of the kidney that can relapse and remit, means come and go throughout the childhood. So nephrotic syndrome is not contagious and not to be spread to others. And children with nephrotic syndromes have difficulty fighting off the infection. Why this study? Why I'm going to doing this study? So families of the children presenting with their first episode of the nephrotic syndrome wish to know whether their child will achieve complete remission and what their child kidney outcome will be. And most children with the nephrotic syndromes are treated with an initial treatment course consisting 3 to 5 months of steroids. So furthermore, we cannot predict which patient will require one or more steroid sparing medication or those who are at the risk of the progressing to end stage kidney disease. So that's why this study is required. Pediatric nephrotic syndrome management is currently one size fits all approach. We rely on 4-week trial and error period to classify steroid resistance, leading to delay non-steroid therapy and exposing 40% of children to unnecessary steroid toxicity. Current predictive tools rely on a single variables or simple scoring systems, so they lack the predictive power needed for the personalized medicines, especially for the complex and longitudinal problem of frequent relapse, FRNS. So our project is the first to integrate the comprehensive set of computed physiological features, including UPCR kinetics, eGFR, and the medications with advanced machine learning to create a personalized prediction model at the time of diagnosis. How? So we are having the 2 steps. Steroid responsiveness means firstly we need to identify the steroid responsiveness. And then if the steroid is not responsive, then we are considering that as a relapse. So we are going to consider the relapse prediction. So steroid responsiveness, we are considering it is in a classification task. So predict the steroid sensitive SSNS and steroid resistance SRNS. There are 2 types of nephrotic syndrome, SSNS and SRNS. So SRNS is typically defined as a failure to achieve complete remission after 4 weeks of the daily standard dose. And if SRNS is there, then the another part is the relapse prediction. To predict the frequent relapse, again, in a relapse, there are 2 types, frequently relapse or steroid dependent nephrotic syndrome. So FRNS is greater than or equal to 2 relapses within 6 months or initial responses, or greater than or equal to 4 relapses in any 12-month period. And SDNS, that is the steroid dependent nephrotic syndrome, is relapsing while on alternate day steroids or within 14 days of the stopping treatment. So these are the 2 main fundamentals behind the nephrotic syndromes. And the variables, which are the variables? So if we are considering the categories, demographic, so age and sex is the variable. Lab, if we are considering the lab category, so serum albumin, total cholesterol, The algorithms used to quantification of proteinuria and kidney functions. So there are some parameters. Then immunity, to check the immunity of the patient. So there are again some parameters. Treatment features are also the most important parameters are here, which are going to consider for this particular study. As far as the literature is concerned, the mainly literatures are based on the nephrotic syndrome. And here I'm considering some papers. There are so many papers published in a PubMeds and various reputed journals. So as far as my study is concerned, my study is regarding with the childhood nephrotic syndrome, especially going to consider with the machine learning algorithms. So I use some papers, some titles are there, the publications are there, and the observations are there. So here some observations. Some papers are using machine learning algorithms. Some papers are using initial treatments. What are the observations of the treatments? And this is something the literature survey. So clinical outcomes also there. Some papers are considering the long-term outcomes, short-term outcomes. And in observations, I'm writing down what are the methods they are using. So as far as the literature survey is concerned, the observations of the literature survey are, as I discussed in the current literature, the limitations of the existing studies related to the risk assessment of the prediction of outcome in childhood nephrotic syndrome revolves around a limited number of laboratory tests. So in addition, the pathogenesis of the kidney disease is complex and multifactorial, making it difficult to simply explain the linear relationship. Machine learning is an interdisciplinary discipline, we know that. That has attracted much attention with the unique learning techniques to simulate human intelligence. It adapts to the diversity of the data to algorithm and can compensate for the prediction of the risk. Therefore, machine learning-based relapse prediction for childhood nephrotic syndrome, this study established a machine learning-based prediction model to evaluate the risk of the childhood nephrotic syndrome. So the objective of my research is to integrate and divide the data of all study subjects, then to study the subject of medical record collected during the admissions, including age, gender, and laboratory indicators. Then I used to construct the model for predicting the risk using various algorithms. And then at last to compare and evaluate the predictive values like the accuracy, precision, recall, and area under the receiver operating curve. So proposed methodology, so I used to classify the supervised learning. This study will innovatively use the multimodal machine learning approach as stated in the research objective. So classifier for supervised learning, so random forest will be used. Then, yes. Then KNN, ANN, so many algorithms are there. Then binary classification I used to consider. Then as a supervised machine learning classifier, so we are already unsupervised machine learning classifier. So this is classification as a diagnosis. So there are so many factors we are going to consider in unsupervised machine learning algorithms. And the main are other classifier, because here we are going to considering some variables like as a serum creatinine, serum albumin, then proteinuria, and these are some factors which are fluctuating in nature. So that's why the parameters that are subject to fluctuations and may change with the clinical courses. So that are also some parameters we are going to consider while doing the study in this particular subject. So this is the diagram of my proposed methodology. Firstly, I need to collect the data, then I need to pre-process this, then feature engineering, then I have to select the model, then train that model, then evaluate the model, and then at last the prediction phase is there. So I need to apply that. At last conclusion, machine learning has a potential to improve the management of the pediatric nephrotic syndrome by generating the early prediction and the customized interventions for advanced nephrology and active treatments. Practical implementation required the integration, thorough validation, and ethical supervision. Additionally, hybrid and ensemble model prove the effectiveness to the address the problem for enhancing the accuracy and provide the personalized treatments by taking the patient-specific data into consideration. Then to identify the high-risk patient, machine learning has the potential to comply transform and healthcare sector, and clinicians may be able to treat patient faster, lower mortality, and improve patients' outcome by embracing these technological advancement and getting past structural barriers. So these are the references. Yes, thank you. Thank you very much.
Prasanna sir,
Yes.
a nice presentation. Yeah, so basically you are going to use machine learning in your work. Am I right? Am I audible?
Hello, sir.
You are going to use machine learning in your work. So is there any specific algorithm that you are going
Hello,
to use?
sir. You are not audible.
Am I audible? Am I audible?
Yes, sir.
Hello?
Yes,
Yes,
sir.
sir.
Yeah, so in your work, you are going to use machine learning. So is there any specific algorithm which you are going to deal?
पेपर प्रेजेंट करना था कॉन्फ्रेंस में
Meghna madam, am I audible?
यस सर यू आर ऑडिबल
Sir, is there any specific algorithm which one you are going to use in your work?
Sir, can you please write it your question in a chat box? Maybe Prasanna sir answer it in
Okay.
chat box. Dear presenter, a session chair question is there any specific algorithm you going to use in your work? Sir, you are mute. Please unmute yourself first. Yes.
Hello.
Hello, yes, sir. You're audible. Please.
Yeah, am I audible, sir?
Yes, sir.
Yeah, sir. Till date, I'm not going to fix any algorithm.
Okay.
I'm reviewing this, but after review all the papers, I'm going to conclude this. It requires an ensemble algorithm, means basically the collection of various algorithms that like the KNN, ANN, then random forest, because XGBoost, because the papers which I have reviewed, many papers use the many algorithms. So that's why if I'm
Okay, no.
concluding, so I need to ensemble that.
Okay, no issue. Thank you. Yes.
Yeah, thank you, sir.
Ma'am, next one. Yeah, thank you. I'm done from my side. Yes, Richa madam.
Yes, yes, sir. We are moving further.
Yeah, yeah.
So the next paper is being presented by the author B. Sindhu, and the title of the paper is A Privacy-Focused Face Recognition System with Cancelable Biometrics.
Yes, ma'am. Can I start, ma'am?
Yes, ma'am, sure.
Ma'am, is my screen is visible, ma'am?
Yes,
Yes, it
ma'am,
is
it's
visible.
visible. You continue, please.
Okay. Good morning, respected session chairs, reviewers, and fellow participants. My name is K. Srivalli from Godavari Global University. Today, I'm here to present our paper titled A Privacy-Focused Face Recognition System with Cancelable Biometrics, submitted as paper ID 621 to ICTCS 2025 conference. These are the contents of my This is the overview of my presentation. I will be covering the following steps: abstract, introduction, literature survey, existing system, proposal system, results, comparison table, with conclusion and the future scope. Let me begin with the abstract of our work. Face recognition is becoming extremely common today in security systems and daily applications. However, most face recognition methods store the original face data or raw feature vectors. If this data is stolen, it can never be changed, unlike a password. This creates a major privacy and security risk. Our work proposes a system that gives accurate face recognition without exposing the original face. Our system works in three major stages. First one is the face detection using hair cascade, which is fast and suitable for real-time applications. Next one is the feature extraction using LBPH, which is it is a simple, efficient, and works well even under different lightning conditions also. And the other one is the canceling biometric template generation, where we can convert the extracted features into a non-reversible form using random projection. Finally, these templates are encrypted using a modern secure algorithm called XCHA20 Poly 1305. This makes the system safe from the data theft, identity misuse, and face reconstruction attacks. And the other one is the introduction. Face recognition has many advantages. It is contactless, easy to use, and commonly found in access control, attendance systems, border security, and mobile phones. However, the biggest problem in traditional face recognition system is privacy. They store raw face images or deep learning embeddings that can reveal the person's identity. If a hacker steals the database, the person cannot simply change their face like resetting a password. This is a permanent damage. So the goal of our research is to design a system that does not store original biometrics, and it uses cancelable templates. It applies the strong encryption, and it also maintains the high accuracy and supports the real-time performances. Our system tries to achieve a perfect balance among these requirements. Coming to the literature survey, many researchers have tried to solve the privacy problem in biometric systems. Early studies introduced the concept of cancelable biometrics, which means transforming the original biometric into a different format that cannot be reversed. If the template gets leaked, you can simply generate a new one, just like changing a password. Later, more advanced methods like homomorphic encryption were introduced. This allows computation on encrypted data without decrypting it, which protects privacy even during processing. But these methods are computationally heavy and slow. Deep learning improved recognition accuracy significantly, especially models like FaceNet and ArcFace. But these models store face embeddings that can be misused to reconstruct the identity. To reduce this risk, recent works introduced privacy preserving deep models, learning, and lightweight IoT friendly architectures. Still, the main challenge remains the same: how to combine the high security, high privacy, and real time performance. This gap motivated us to propose a system that is both practical and privacy safe. And coming to the existing system face recognition always generally work well in accuracy, but they have major security limitations. Most of them store raw face images, facial feature vectors, deep learning embeddings. These stored templates are permanent. If they are leaked, we cannot replace the person's biometric identity. Some systems use encryption, but even then, the template is still permanent. If decrypted, the original phase can be exposed. They cannot be revoked. They require high computation. So existing systems do not provide a complete privacy solution. This is where our system brings innovation. Proposer system. Let me now explain our proposer system, which is the core of our work. Our approach has 5 main steps. First one is the face detection, next one is the feature extraction, and the cancelable template generation, encryption, and the last one is the matching. And coming to the first one is the face detection. We use hair cascade, which is fast, lightweight, and works at real-time speeds. It detects the region of interest from live video or images. Next one is the feature extraction. The next step 2 is we use LBPH, which is local binary patterns histograms. We choose an LBPH because it works well under varying lightning. It is computationally light. It does not need large data sets. It is excellent for real-time systems. It converts the face into a set of patterns and histograms. And the step 3 is the cancelable template generation. This is the actually heart of our privacy system. We take the LBPH feature vectors and apply random projection. This transforms the features into a new space. The benefits of this cancelable template generation is the template is non-reversible. If even if someone gets the template, they cannot reconstruct the face. The original biometric remains safe. This makes our system fully revocable. These are the results of my work. We tested our system on standard datasets and real-time webcam inputs. The results were very promising. Here are the key results. Accuracy is 93 to 95 percentage, and the false acceptance rate is 2.1 percentage, and the false rejection rate is 3.8 percentage. It is the real-time speed. It takes 12 frames per second. We also generated cancelable biometric template that look like a colored pattern matrices. These patterns do not reveal any information about the person's face. The system works smoothly in real-time video scenarios and provides strong resistance to spoofing, replay attacks, and template reconstruction attacks. And this is the comparative analysis. When we compare with the traditional systems, our system provides revocability, which most systems do not support. Our system never stores original images or raw images. Strong encryption adds an additional layer of security. Accuracy remains high despite privacy transformations. Processing speed is real-time and lightweight, so our method is an improvement in both privacy and real-world usability. To conclude, our proposed privacy-focused face recognition system successfully addresses the major challenges in biometric security. We achieve the accurate face recognition, data privacy through cancelable biometrics, strong encryption using XCharger20 Poly 1305, and it achieves the real-time performance, revocable, and secure templates. In the future, we can plan to integrate deep learning models for better accuracy, optimize the systems for mobile and IoT devices, and multimodal biometrics like fingerprints and voice. We can use the edge computing to reduce cloud dependency, to explore the blockchain for secure distributed storage. With these future enhancements, our system can be highly useful in access controls, smart cities, surveillance, and secure authentication. And these are the references I have been taken. Thank you for listening. And that's it, ma'am.
Okay, ma'am. Nice work. Nice presentation. So, madam,
Thank
just assume you are ready with your system. So,
Sir.
who will be your stakeholders? Who will be your stakeholders, or who are going to use your system?
So can you repeat the question, sir?
You are ready with your system. Just assume.
Yes, sir.
So, who are going? Yes. So, who are going to use your system? Am I audible?
Sir, am I audible, sir?
Yeah, you are audible.
Our system can be used by organization applications where secure and privacy preserving identity verification is required. The main users of our system include first government and public sector organizations, sir.
Okay,
Such
no
as,
issue. What? Yeah, yeah, got it. What is the cost of your project?
sir,
What is the cost of your project?
we are not still at decided, sir.
Okay, no issue. Thank you.
Thank you, sir.
Thank you, ma'am. Now we'll move further.
Am I audible?
Uh, yes, you
Hello?
are.
Yes. Can I present now?
Just a minute, ma'am.
Okay.
So now our next paper is being presented by Ms. Purva Trivedi, and the title of the paper is Application of Machine Learning and Computer Vision Technology in Online Signature Verification System. Ma'am, you can present.
Good morning, all. Hello. Am I audible? Good morning, all. My
Yeah,
topic
ma'am.
of
Good morning.
Good morning, sir. My topic of presentation is application of machine learning and computer vision technology and online signature verification system. Basically, this paper is general study of various literature review. Nowadays, we have seen that very rigorous research is going on the field of computer vision as well as machine learning technology to develop reliable system for signature verification system. Why we need signature
Ma'am, sorry
verification?
to interrupt. Your screen is not visible.
Oh, screen is not visible. Wait. Now visible?
Yes, it is visible now.
Okay. Nowadays, rigorous research is going on the field of computer vision as well as machine learning to develop reliable system for signature verification system. Why we need signature verification system? Because to stop forgeries cases in each and every crucial application and identification process, we use signature. So signature verification is very important. In this paper, I am presenting biometric system-based signature verification system. In biometric system, we use biological feature of people for recognition purpose. The aim of using biometric-based system in recognition is identification and verification of people. Biometric identification device has been installed in various organizations and public services such as airport, banks, financial institute, where day-to-day identification and verification of person is a fundamental process for security reason, and to minimize the chances of forgery rises due to false authentication or without authentication. Biological features we have categorized into two type: psychological physiological feature and behavioral features. The biometric system, whose verification system based on authentication by using one of them features like person's fingerprint matching, DNA matching, facial feature, are fall under the category of physiological feature based verification system, and there is no impact of aging on this feature. They remain constant over that time. While biometric verification system based on authentication by using person's signature and voice feature are fall under the category of behavioral feature. The main concern associated in behavioral feature that these features are changing with time. Person signature and voice both get affected due to shaking of hand, voice stumbling due to age or other physical factors. So the risk of imitation increases, and it is a bit challenging task to design an accurate system for recognition purpose using behavioral features. This paper present review on online signature verification system domain and application of ML technique in extracting signature features. we have made some literature review based on our studies, where in this study we have seen that Greece et al. Suggested a verification system that is based on statistical test and time constant data. Which data set is used in the system, and features like pressure, velocity, coordinate are tested using this system. Fayaz et al. Proposed an autoencoder-based system to collect information about different features of signature. SVC 2004 signature database is used in this system, resulting in reduction in error and improved accuracy. Lech and Gavesky proposed a system uses both static and time domain features of signature in the system. Data related to pain pressure during signing process is collected by tablet. Dynamic time wrapping technique is used in this process. One of author Antal proposed two method system based on function based method and second feature based method. Gia et al. Proposed a system rely on shape, contour, and financial features. In this system, in order to verify sample signature from reference signature, shape, contour, dynamic time wrapping technique was used in this. EAR equals to 2.39% is calculated. Next, authentication. Authentication, the accurate authentication can be done by accurate identification and verification of person's signature. Authentication is crucial for enhancing security and detecting the forgery. In signature verification process, person is verified by mean of identify her own signature. The signature verification system and identification system both are necessary for stopping forgery cases. So first is identification system step and second is verification system steps. अगर हम if you see the identification step, the input signature is given for authentication is compared from the signature stored in dataset. After the comparison result will be concluded from the signature analysis, and they will provide class according to that. In signature verification system, data pre-processing, signature feature extraction, classification, and verification of genuine and false. These steps are very important in data processing. The first step include scanning and pre-processing of test signature. Some features are extracted from test signature, and the last process in the classification stage in which extracted feature from the test signature is compared with reference signature, which is stored in database. After the comparison, class is allocated to tested signature sample. The stage at which signature is analyzed whether it is forged or genuine is called verification stage. The verification system has same steps as identification system. The difference occur in fourth step. In identification system, on fourth step, class is allocated to test signature. On the basis of class, in last stage of verification process, the authenticity of signature is checked. The complete system process is carried out by two techniques: model-based verification technique, in which CNN, HNN, SVM model are for verification is used, and distance-based verification, in which distance-based verification system test signature is compared with reference signature using dynamic time wrapping technique. Next is signature features. Online signature features are mainly categorized into two parts: parametric feature, function based feature. Parametric function features are also divided into two types: component based and function based. Parameter based features based on monitoring and recording of time required to complete sign and number of times pen tips occur along with spatial characteristic. And function based features, this feature monitor and record the pressure and time stamp of pen. Signature forgeries. The forgeries from handwritten signatures is divided into three types: random forgeries, unskilled forgeries, and skilled forgeries. The forgers does not know signer's name and sign pattern. This type of forgery can be traced out without many efforts, just from simple visualizing the sign. Unskilled forgery, in this forger aware from the signatory name but does not aware from his or her signature pattern. Skilled forgeries are those type of forgery when forger is aware from the signatory name and signature pattern, and this type of forgery is done by the professional forgers, and the purpose is to stop the skilled forgery cases and to efficiently detect the difference between uh, for genuine signature and forged signature. If next stages of online verification signature verification system, the online signature verification system has divided into this blocks: data acquisition, pre-processing, feature extraction, and classification. In data acquisition, the data is signature. This step include the capturing of signing process of person, like motion, pressure, and velocity of pen. The movement of pen is captured in such a degree that if pen in right hand, the position of camera is at left side of hand, facing the palm, and if the pen is left, then the camera is held at right side of the hand. This step helps to gather signing video of signatory. Then pre-processing step include background subtraction, noise removal, binarization, and area opening. These steps are performed one by one on the recorded signature images obtained from video of a signatory. In in this background subtraction step, only captured image of signature from each frame is stored, and remaining background area recorded during signing process is removed. In this process, pre-processing, we want to do one thing: noise removal. In this step, unwanted images from the signing video has been removed. Again, we perform one more step: binarization. In binarization step, pan region is presented in white region, on all other region is in black pixel. One more step is
Sorry
area
to
opening.
interrupt. Ma'am, this is a gentle reminder for the 10 minutes time limit.
Okay, so give me just 2 to 3 minutes. I will finish. Just 2 and 3 minutes.
Ma'am, sorry for interrupt. You have last 1 minute to conclude your
Okay.
presentation.
Okay. The last conclusion is the review of recent online signature verification system has been presented in this paper. Different data sets are discussed. Also, different feature extraction classification techniques such as global feature, local feature, static and time domain feature, shape contour, function-based feature, SCDWT, and deep convolution method have been compared in terms of merit and limitations. Researchers must consider following factor in the future research work. We have noticed that some data sets have limitation of number of sets. This is need to design data set to handle large number of data. The identification system must be developed to extract more accurate features from the signature, and so more features can be provided as an input to machine learning system for accurate decision. Thank you.
Okay, madam. Good presentation.
Thank you, sir.
As per my knowledge, many more systems are available for this signature verification.
Yeah,
So how
very
you
minimum things are available. I have sir मतलब बहुत I just made a review, and we are working over it to bring present मतलब practical development of signature verification system user computer vision technology.
okay? Thank you.
Okay, sir. Thank you.
Thank you. We have our next paper presented by author Pantham Naganjali. The title of their paper is Dark Web Classification with Text CNN and Topic Modeling Weight Approach.
Yes, ma'am. Am I audible?
Yes, ma'am, you are.
Okay, ma'am. I'm Good morning, respected chairpersons and all participants. I am Pantam Naganjali, and today I am presenting our research paper with paper ID 622, which is titled as Dark Side of the Web, Dark Web Classification Based on Text CNN and Topic Modeling Weight Approach. This research focuses on using deep learning and topic modeling techniques to classify dark web services, which is very important for improving cybersecurity and threat detection. Um, my presentation contains Ma'am, am I audible?
Yes, you are.
Yes,
Please
ma'am.
play slideshow.
Is my screen visible, sir?
Your screen is visible. Please play slideshow.
Okay, sir. My presentation contains abstract, introduction, literature survey, existing system, proposed system, data sets, system architecture, conclusion, and future scope. In that, first one is abstract. We have selected this project because as the dark web is the hidden part of the internet that provide strong anonymity to its users. While anonymity has positive uses, it is also widely misused for illegal activities such as cybercrime, illegal trading, and data leaks. Due to anonymous nature of the dark web, it becomes extremely difficult to track and classify its content manually. In this paper, we proposed a deep learning based classification approach that contains latent Dirichlet allocation LDA for topic modeling and text CNN for classification. While coming to introduction, the internet can be broadly divided into three layers: surface web, deep web, and dark web. Surface web includes normal websites like Google and Wikipedia. Deep web contains private data like emails, bank accounts, and internal systems. Whereas dark web, which is a small but hidden part of the deep web, this dark web requires special browsers such as Tor, I2P to access it. Initially, the dark web was designed to protect privacy, but over time it has become widely associated with illegal activities due to its anonymous nature. The main objective of this research is to develop an accurate and efficient system for classifying dark web services based on textual content. While coming to the literature survey, these are some of the literature survey we have overviewed. The first one is dark web text classification by learning through SQL optimization. In this literature survey, the dark web has become the largest repository of unauthorized information. In the first paper, I have considered they used the SVM algorithm to understand the algorithm's efficiency for a proposed model. This paper classifies dark web data with optimization techniques, and they use text-based keywords from more than 1800 websites. And while coming to the dark web illegal activities, crawling and classifying using data mining techniques, in this paper, they had collected and classified illegal activities as a challenging task as they are difficult and time consuming. We have considered these papers and we have built our model. While coming to the existing system, uh, these are the existing systems mainly use traditional machine learning approaches. This system converts the text into numerical features using methods like bag of words, TF-IDF, etc. After feature extraction, classifiers such as SVM or naive-based are used in the existing systems. While these models are simple and fast, they do not capture semantic meaning or word relations effectively. The disadvantages of the existing system are their loss of contextual information is there, and they give equal importance to all the words, lower accuracy on real world dark web data. While coming to the proposed system, to overcome these issues present in the existing system, we propose a new classification framework. First, we apply LDA, latent Dirichlet allocation, to identify hidden topics in the dark web text. LDA assigns higher weights to words that frequently occur together, helping to remove irrelevant data. Next, these topic weights are provided as input to text CNN, which is capable of learning complex text patterns. This combination allows the models to focus on meaningful features and improve classification accuracy. The advantages of this proposed system is it is a better contextual understanding of text. It reduces the noise due to topic modeling and provides higher classification accuracy. Uh, Uh, to further improve performance, we extended our model by extracting features from the LDA text CNN architecture. These features are then trained using a CNN 2D model along with a dropout layer. The dropout layer helps eliminate irrelevant features and reduce overfitting, leading to better generalization and higher accuracy. This is the system architecture of our model. While coming to the datasets, these are the datasets collected from the Kaggle and consists of dark web service descriptions. The data was cleaned and pre-processed before applying topic modeling and classification algorithms. These pre-processing steps play an important role in improving model performance. These are the results of our dark web classification project. While coming to the comparative analysis, our model accuracy is more when compared to the existing systems. This is the comparative analysis score. In conclusion, this research demonstrates that integrating topic modeling weight with deep learning significantly improves dark web service classification. The proposed LDA hybrid text CNN model achieved the highest accuracy of 96%. This approach can be effectively and efficiently used in cybersecurity applications to identify suspicious dark web activities and support threat detection. In the future, this work can be extended to real-time dark web monitoring systems. Additional improvements can include faster processing, larger datasets, multi-language support. This is about my paper. These are the references considered. Thank you, ma'am. Thank you, sir.
Yeah, okay. Good presentation. So
Thank you.
basically, you are going to work on what? Dark web classification. Am I right?
Yes, yes, sir.
Yes. Yes. So just tell me 4 or 5 rules for that classification, which one you have considered.
Rules for
Have you
classification,
considered
sir.
some rules? Yes, yes.
Yeah, sir. We used LDA, text CNN, and topic modeling weight approaches, sir. By using Tor website, Tor, not website, we gathered the information from the dark web.
Okay.
First, the text-based classification rule we have applied, sir. In this, classification is performed only on textual content of dark web services. The
Uh,
second rule is pre-processing rule. The raw text,
okay.
the all raw text must be cleaned before classification, sir. So we used pre-processing rule. In this pre-processing rule, it removes special characters and symbols, removes stop words, and convert text to lowercase, and performs tokenization. And another rule is topic extraction rule, which is done by using LDA. In
Okay,
this,
no issue. Yeah, understood.
okay, sir.
Yeah, thank you.
Thank you, sir.
Now we have another paper. The author of this paper is Dhyaneshwar Natha Vahval. The title of the paper is Data-Driven Prediction Framework for Best Match Donor Selection and Survival Estimation in Liver Transplantation. Sir might have not joined. We'll move further. Now our next paper is being presented by author Shivakami B.O. Her paper title is Digital and Technological Readiness Assessment Enabling Green Finance in Emerging Enterprises.
Thank you. Let me present my paper. So just give me a second.
Yes.
Please let me know if you could see my screen. Now, can you hear me?
Yes, you're audible and
Yeah.
the screen is visible.
So, a very good morning, everyone. So, this is Shivakami here, full-time PhD research scholar at Amrita School of Business, Coimbatore. So, before I would begin my presentation, I would like to thank my supervisor, Dr. Suresh, who has been great support and guidance throughout this research project. So, I'll be sharing about my study titled Digital and Technological Readiness Assessment Enabling Green Finance in Emerging Enterprises. So the agenda for today's presentation is I'll start with the introduction by setting the context and the background, followed by the research gap and the research objectives, and how the research methodology aligns with the research gap and the context, followed by the findings from the study and the conclusion and the limitations and the implications of the study as well. So to start with, in today's world, there is a rising greenhouse gas emissions and fast climate changes that is harming the environment all around the world. So a major reason for that is the industrial activities and our continued dependence on the fossil fuels. So these problems have become more and more serious as the industrialization has begun. So in response, the economies have adopted net zero targets. For instance, the recent COP30 climate finance amendments were also being highlighted. So these are the responses that the many economies all around the world have begun integrating climate resilience and environmental sustainability into their national developmental agendas. So, however, in the case of emerging enterprises, so adopting green finance or green investments is a bit difficult because of the lack of returns that the green investments would provide, and also the operational efficiency has been compromised. So that is the reason there is a adopting green investments or eco-friendly strategies is not straightforward. So these enterprises require strong financial support as they cannot afford to compromise on the operational efficiencies. So despite the growing emphasis on sustainability, private sector participation in green energy projects remain very limited in developing countries because of the low rates of returns and high risk associated with green investments. So this is where green finance comes into place, and green finance helps in channelizing the financial resources towards the sustainable and environmentally responsible projects. So, through increased environmentally beneficial investments, and businesses can move closer to achieving sustainable development goals. And some of the instruments are green funds, green bonds, and green central banking initiatives. So, in this case, technology plays a major key role from the literature review that we have done before. So it acts as a key enabler for climate action and transformation of capital markets by improving the productivity and innovation and enhancing the standards and reducing the environmental risk in the financial domain. In the financial sector, service sector, this technological transformation is commonly referred to as fintech, where more of these technologies such as IoT, blockchain, big data analytics are not only reshaping the financial systems but also effectively applied to green finance, which helps in green growth. So, recent studies further suggest that the green fintech innovations significantly strengthen the positive impact of green finance on sustainable development. And given the growing importance of digital and technological enablers, this study focuses on assessing the readiness level of emerging enterprises for adopting green finance using the enabler digital and technological enablers. So in this context, the digital and technological enablers refers to an enterprise's technological infrastructure and digital capabilities, especially for the support of green finance adoption. So, yeah, given the context here, the literature review has been done where a substantial body of research highlights the importance of green finance and its practical role in enabling green investments and sustainable projects. And on the other hand, within this domain, digital and technological factors are identified to be a significant and influential factor in green finance adoption. And there are also extant literature which explores the intersection of fintech, green finance, sustainable development, the digital economy, and environmental sustainability, which offers both theoretical and practical insights. And one gap is that existing studies largely emphasize the digitalization and fintech with limited focus on the direct role of green finance adoption. And empirical evidence is predominantly drawn from developed economies, especially from Europe, US, and other advanced regions. And the context of developing and emerging economics remain underexplored, both in the context of contextual and empirical side. And methodologically, most studies rely on panel-based econometric techniques. For instance, panel unit root test and co-integration. So, with limited application of MCDM techniques. So, in this research, to fill all these research gaps in the literature and also to address the contextual need to study the digital and technological enabler, the objectives of the study are to identify the relevant criteria and attributes of the digital and technological readiness enabler for green finance adoption, to assess the readiness level of the digital and technological readiness enabler for green finance adoption in emerging enterprise, and to identify and address the weaker attributes within the digital and technological readiness enabler for green finance adoption. So for this, the fuzzy logic method has been used, which is proposed by Zade, 1965 year. So this study this methodology helps in addressing the uncertainties and the ambiguities that lies in the study. This method captures all the gray areas or the clear boundaries which are not captured in the other conventional studies are being captured in this method. The technique converts the verbal expressions into numerical values And this enables a quantitative evaluation, allowing them to convert it back to the natural language form. So for this, a case organization has been identified, and in Indian medium-sized enterprises on selected. Um, so in this case, the medium enterprise manufactures plumbing solutions, PVC, UPVC pipes, and CPVC for both residential and commercial pipes. So it engages more into material recycling and follows circular economy principles. That was the main reason the organization was selected. So on the basis of the literature review and expert inputs, the attributes that contribute to the attributes and the criteria that contributes to the adoption of green finance from a digital and technological perspective were identified. So these are the criteria and the attributes that were identified from the literature review, and also some kind of inputs were also been implemented here. So first being the financial technology, and secondly technological interoperability, and data management capability are the three criteria that clubs into the various attributes. So to explain the methodology, the first step is assigning the importance weights to the criteria and the attributes based on the 7-point scale. It ranges from very high importance to very low importance. For this, three industry experts from the financial department and two accommodations in finance with at least 3 years of experience were involved. And the second step is to assign the performance rating of the case organization for each of these attributes only. So the case organization experts were asked to rate the performance of each of these attributes. So the selection was again based on the experience, seniority, and willingness to participate. And there are three levels of calculations that were carried out. So one being the average fuzzy rating with, and average fuzzy weight, which is for the performance and which is for the importance. Weight is for the performance. Weight is for the importance, were calculated, which were further used to compute the fuzzy digital and technological readiness index for green finance, which is the FDTRI index that was found in this paper. So the FDTRI is matched with the linguistic expression by converting the triangular fuzzy number, the index that was converted back to the linguistic variable using the Euclidean distance method. And third level of calculation is the principal obstacles to or the weaker attributes are identified by calculating the FPII, which is the fuzzy performance importance index and ranking score. So this helps by identifying the weaker attributes, necessary
Sorry to interrupt, ma'am. This is a gentle reminder for the 10 minutes time limit.
Thank you. Necessary actions are then proposed to eliminate the obstacles, while continuous improvements are a pathway towards attaining the state of extremely ready state. So moving to the findings, the FTTRI index is 2.34, 3.744, 5.166. So this is then converted back to the Euclidean distance method. As we could see in the figure, it is the organization is low ready for from the perspective of digital and technological side. For the adoption of green finance, for the green finance, it is at a low ready state. And by identifying the FPII, the ranking scores are made. So the management threshold has been fixed at 0.9, and the minimum value from the attributes was 0.3, and the maximum is 1.8. And these are the weaker attributes that were being found. So for instance, use of digital banking and payment systems to facilitate inclusive green finance access, cloud enabled and secure infrastructure for sustainability reporting, and structured systems to collect, analyze and manage green finance related data, implementation of cybersecurity protocols for digital finance infrastructure,
Dear
compatibility of.
presenter, sorry to interrupt. You have last 1 minute to conclude your presentation.
Okay. So from this presentation, we were able to give the policymakers and the financial institutions and enterprises to enhance the green finance through digital and technological solutions by addressing the weaker attributes and also by prioritizing on the digital side of the infrastructure. Thank you.
Hello.
Yes, sir.
Yeah, ma'am, your topic is very interesting
Thank you, sir.
and your presentation is very good. Yeah, but I have one doubt.
Yes, sir.
Really, is it feasible in India to adopt green finance?
With time, it is actually possible, sir, because now, with the context of very fragmented nature that we have right now, it is not. But with time, that's why we are finding the readiness and how we could set an environment which would be help us in adopting green finance. And it is also very much important that we implement green finance into the place because just having finance that just focuses on the profits and the operational efficiency wouldn't be a sustainable way to grow forward. So it is very important to bring in green finance into place. This is what from the literature review that I was able to find. That's why we started digging more into the subject.
Yeah, okay, no issue. Thank you, ma'am.
Thank you, sir.
Thank you, ma'am.
Thank you.
Now moving on to our next presentation. This paper is being presented by author Anil Kumar Gupta, and the title of the paper is ICT Guidelines for Bilingual Indian Government Websites.
Hi, good morning. This is Anil Gupta here. On behalf of me and my colleague, Dr. Kajal Pandey from CDEC, we both are from CDEC Pune. I'll just go ahead and present. I'm sharing my screen now. I hope it is visible.
Yes, sir. Yes.
All right, I'll just start. So, the topic is basically ICT guidelines for bilingual Indian government websites, and it is in short called GIGW, Guidelines for Indian Government Websites. Nowadays, since Government of India is insisting on Hindi also as a compulsory for all government websites, government offices, so same way the websites also should be adopting bilingual policies for preparing the website, which can be seen in English and Hindi depending on users' choice. So just starting with the background of GIGW, started from foundational standards, started in GIGW 1.0 in 2009. It was foundation was laid, focusing on enhancing accessibility and usability and informity. Then 2019, next version came, GIGW 2.0, which integrated modern practices and make a significant step forward by incorporating stakeholder feedback and updated standards. Followed by latest one like as present GIGW 3.0. It is a strategic framework for stronger topic focus on user-centric design, robust security, multi-device compatibility, and global compliance. And to just add that GIGW is not a technical, it's just a strategic framework designed to build citizen trust and ensure efficient delivery of public services in digital India era. When we say public services is important because see, all public will probably be try to see the contents on these websites which are offering government services in their native languages or language which they are comfortable with. So primarily these will be Hindi and English are two main, but state governments probably have their own regional languages. When we talk about we should employ the variety of approaches, including which sorry. All right, I'll just continue. Meantime, the next is the 4 pillars of world-class bilingual website is all part of JW's standard. Pillar 1 is content creation. I'll elaborate on these each of the pillar in next slides. Pillar 2 is user-centric experience. Pillar 3 is technical and search integrity. Pillar 4 lifecycle and governance. Moving forward, Pillar 1, content foundation. So quality and consistency of information is the bedrock of user trust. Pillar ensure that content is comprehensive, synchronized, and culturally precise across both languages. So which I want to emphasize here, that we are saying both languages, but it's primarily Hindi and English, but it could be multilingual also. JH will support for multilingual also. And the key mandate for content integration: ensure full content availability. All content include text, navigations, buttons, and photos must be available in both English and Indian language. Treat both versions with equal priority. Synchronize all updates. Any modification, new content addition must be implemented simultaneously in both languages. Basically, all language versions should be synchronized. Content should be similar. It should not then happen that English is showing something and other language is showing something else. Maintain quality and accuracy. Content must be regularly updated for timeliness, and both language versions must convey the same user message with uniform tone and style. And standard transliteration. Maintain a shared glossary for technical terms, brand names, modern concepts, for example, APR, download, etc. See, this is very important for at least organization like us, CDAC, where we have standardized terms for like param, which signifies our supercomputer. So these are like kind of terms which should be acronyms, you can say. A glossary should be maintained and these should be translated as it is. And this consistency should be maintained across both multiple languages, all through a digital environment. Coming to pillar 2, user-centric experience. Beyond accurate content, successful government website must be intuitive, accessible, and respectful of users' content. The pillar focus on creating a seamless and inclusive digital journey. Ensuring accessibility and engagement for all. So in this, comply with WCAG 2.0. WCAG is basically Web Content Accessibility Guideline 2.1. It ensures that it is accessible for people with disabilities, including keyboard navigability, text, and alternatives for non-text content. So this is very important for people with disability who should be able to access the website without too much of hassle. So content should not be. I can give an example, like in my case, I'm handicapped, my left hand does not work. So if I have to access a website where you have drop-down menu and you want to select multiple items from drop-down menu. So generally it requires you to press Control key and click each item with a mouse button. But for a person like me who cannot use left hand, I can only use one hand to press either mouse or control key. So I cannot put both the buttons together. So then now website need to be designed in a way that I can use, people like me can also use it. That's what WCAG 2.1 ensures. A way, or when website designer should be able to design a website for people like blind people, how they will be able to access it. Maybe audio is required, speech input should be able to take input from speech. Then provide disruptive alt text for all visuals. So basically all visuals should have alternative text in relevant language. For multilingual or dual language, you should use dual language prompt. For example, all feedback, message, error, prompt, notification must be displayed clearly and simply in both languages. But all said and done, I think feedback mechanism still has to be in English. Implement clear channels for user to report translation errors, consistency or accessibility issues, and enabling into continuous improvement. Pillar 3, technical and search integrity. A seamless user experience depends on robust care and well-architected technical foundation. The pillar addresses the database security, search engine optimization required for high-performance site. Database optimization and scalability. Basically, database architecture has to be scalable and capable of handling large volumes of data and concurrent users. So if to summarize this, basically if amount of data a site is holding is large and number of users are large, depending on user, it should not that the website starts hanging once number of users, say 5, maybe beyond 10, 15 or 100 users simultaneously accessing the website. So it should not be hanging. It should be scalable to handle large number of website users simultaneously. And so the database also should be able to handle, and fast indexing and data retrieval is important. Robust security and data protection. Employ multi-layered security measures, including HTTP encryption, regular vulnerability assessment. So VAPTA is very important for all government websites. I think it is a basic requirement that website should be VAPT certified. And to ensure the large reach of website contents through search engines, advanced search engine optimization, which is able to tackle the vernacular language or local regional content searchability as well as local language searchability also. Accordingly, optimize meta tags, semantic HTML, schema markup, improve discoverability and with organic search ranking for relevant keywords in both English and Indian language to enhance site visibility over the search engine also.
Sorry to interrupt, sir. This is a gentle reminder for the 10 minutes
Yes,
time
ma'am.
limit.
Just I think one more slide. I will be done. Building a scalable and secure foundation. So building a bilingual data, that's what I just mentioned in previous slide. Using a robust CMS, their content management system. Implement language-specific content coding. Ensure secure input and policy transparency. And this is the last slide. Optimizing for discoverability bilingual SEO. That's why I think mentioned the previous slide, previous to previous one, where I talked about search engine optimization. So by using optimized meta tags, offline attitude, which basically means that depending on the multiple, it should have a tag of which language content. Accordingly, content should be searchable by search engine and the user also. And localized URL, basically URL should be able to indicate like you have /en is indicating English language, HI is for Hindi. That's how the URL should also have those kind of things. And that is it. Pillar 4, life cycle and governance. Continuous content updates and review, performance monitoring and optimization, user feedback loops and iteration, policy and compliance audits. This is some of the which we covered already, so I will not repeat that again. This is the last slide. And I'll conclude with this. What we have tried to present is a GIGW standard for as guidelines for Indian government website. Thank you.
Yeah, thank you, sir. I learned many more things from your presentation.
Thank you, sir.
Yeah, and definitely I'm not going to ask you any questions because of what? Because of two things. First one, you are working with CDAC Pune, and second is what? You are more experienced than me. But definitely I learned many more things from your presentation.
Sir, you are very modest, sir. I will not say you are a professor, sir. I am just a researcher.
No, no, sir.
Thank you very much, sir.
Yeah.
Thank you.
Thank you, sir.
Thank you, ma'am. We are dropping off.
Now we have our next paper presentation by the author Meha Srivastav. Her paper title is Performance Analysis of YOLO 5, YOLO 6, and YOLO 7 for Real-Time Object Detection.
Yeah, good morning, ma'am. Am I audible?
Yes, ma'am, you are.
Okay. Screen is visible?
Yes.
Okay, good morning, everyone. I'm Meha Srivastav, and today I will be presenting my work titled Performance Analysis of YOLO V5, V6, and V7 for Real-Time Object Detection. These are the contents which I am going to cover in my presentation. Object detection. Object detection is basically a fundamental task in computer vision that involves identifying and localizing objects within images or video streams. In real-time environments, detecting and tracking multiple moving objects is one of the challenging issues due to speed constraints and environmental variations. Since objects represent the most meaningful information in an image, so there is a strong need for efficient and accurate object detection techniques. So by assigning predefined labels, object detection systems help extract semantic information from visual data. Now, these are the challenges which we generally face in detecting the objects in real-time working environments. It includes object classification and localization, high speed constraints are always there. Other challenges are scale, illumination, and change of appearance, then occlusions, multi-scale trainings, etc. And these challenges motivate the need for optimized detection frameworks like YOLO. Now, YOLO, which stands for You Look Only Once, is a single stage detector that performs object detection in a single forward pass of the network. Unlike two-stage networks such as RCNN, YOLO is designed for real-time performance. Although other single-shot detectors also exist like SSD, but YOLO consistently offers better speed accuracy trade-offs, and because of its fast inference, YOLO is widely used in applications such as traffic monitoring, surveillance, autonomous driving, and safety systems, etc. These are the successive variants of YOLO, starting with YOLO, which was evolved in 2016. So these are the workflow process of YOLO, how YOLO works. The core idea of YOLO is to treat object detection as a regression problem, predicting bounding boxes and class probabilities directly from the input image. And this unified approach, it enables fast detection, making YOLO suitable for real-time systems. It is also known for lightweight design, being this is the background basically. YOLO 5. Our main research topic is a comparison of YOLO 5, 6, and 7 versions. So YOLO 5 is extremely fast and is lightweight design, 90% smaller than YOLO 4, its previous version. Then YOLO V6 introduces improvements in backbone, NAC, head design, and training strategies, which uses efficient reparameterized backbone and reparameterized path aggregation network. YOLO V7 further enhances the performance and achieves the state-of-art accuracy while reducing parameters and computational costs, especially in real-time FPS ranges. This is an individual description of YOLO V5. Her YOLO V5 is PyTorch based and it is easy to deploy. It offers multiple variants to support different performance requirements. Its architecture consists of CSP Darknet 53 backbone, SPFF and CSP PAN neck, and a YOLO V3 style detection head, which is optimized for fast inference on GPU and edge devices. Then YOLO V6 is designed with an industry-focused approach. It uses an efficient reparameterized backbone and reparameterized path aggregation network as a NAC, which enables improved FPS while maintaining competitive accuracy. Its anchor-free design further enhances speed and deployment efficiency. YOLO V7 introduced several architectural innovations, and these include EELAN, compound model scaling and trainable bag of freebies, and reparameterization techniques. Together, these improvements significantly boost detection accuracy while preserving real-time capability. The main objective of this paper is to evaluate and compare YOLO V5, V6, and V7, and the primary focus is on comparing inference speed and FPS. This is the experimental setup which I have used in my paper. The COCO data set which is used is COCO data set. Hardware is GPU based inference environment, and Python Anaconda environment is used to perform the experiment. Now these are the evaluation parameters which I have evaluated during my work. Inference time, average inference time per frame, and frames per second. The results which I have got is average inference time per frame is lower for YOLO V5 and is better than others. So speed is better than others in case of YOLO V5. And YOLO V6 is somewhere lying between YOLO V5 and V6. This is the result of comparative analysis which I have done for some video frames, real-time video frames. Here I've taken one of the video which is having 527 frames, and on comparing and on working with Anaconda, the total inference time, we have found that YOLO 5 is having lowest inference time and highest frames per second. And same is achieved with 749 frames. 749 frames. Again, YOLO V5 is having a lowest inference time and highest frames per second. So from these results, the conclusion is that if speed is taken as a priority parameter, then YOLO V5 is one of the best solution, assuming accuracy is acceptable. While YOLO V7, it is comparatively slower, but it is preferred in cases where detection accuracy and robustness is prioritized over speed. So future work can be done in the field of robotics, autonomous vehicles, surveillance, integrating transformers to improve robustness, etc. Although already the work is going on in this, but in order to increase the parameters, like we can work for MAP, precision, recall, F1 score. So more work can be done on this. These are the references which I have used during my work. Thank you.
Okay, madam. Madam, just consider I have two applications.
Yes, sir.
One is small application and one is big application.
Regarding, sir, YOLO?
No, just consider I have two applications. And
Okay.
for both applications, I have to use YOLO.
Yes, sir.
Yeah, one is small and one is big.
One is?
Bigger application.
Okay, sir.
Means small project and you can say large project or major project.
Yes, sir.
Yeah, so are you going to suggest me same YOLO for both applications?
Sir, same YOLO can be used, but again the priority will be given ki where you want to access the accurate data or speed. Actually, YOLO V7 is dedicatedly used when you want to work for accuracy. Because comparatively, from time point of view, speed point of view, actually, YOLO V7 is accuracy oriented model. YOLO V5 is a result, speed oriented. So we have to take into consideration what are the parameters which are needed.
Okay, madam, no issue. Thank you.
Thank you, sir.
Moving on to our next paper. This paper is being presented by Ria Bohra, and the title of the paper is Cancer, a deep learning based system for automated skin cancer detection using binary classification.
Okay, hello, am I audible?
Yes, sure.
Okay. Okay, so my screen is visible?
Yes.
Okay. So, good morning, everyone. Skin cancer is one of the most common cancer globally, yet early detection remain a challenge for millions. Today, I am presenting Skincer, a deep learning-based system for automated skin cancer detection using binary classification. So, we have developed this system to solve the black box problem in automated detection. My name is Ria Vora, and I represent Charusat University. So, okay. So here is a brief roadmap of my presentation. I'll start with the critical problem we are solving, review the current research landscape, and then dive into unique methodology before sharing our result. Okay, so let's start with the abstract that we have developed AI system to analyze lesion image, automatically classifying them as benign and malignant, which is cancerous and non-cancerous images. So we have focused on the people of all the ages. Most of the data set only contain age group to 18 to 14 years old. So we are focusing on all age group people, and then we have used unit model to isolate noises from the skin lesion images. So going on to the introduction, why this matters. Skin cancer cases are rising due to global warming and UV exposure. The main challenge is that malignant lesions often look visually identical to benign ones. So currently the gold standard, as we all know, that biopsy is there, but it is very painful and very slow. In rural areas, there is a less access to dermatologists is very limited. So we need a faster and accurate that works for everyone and regardless of their age. So then where our cancer comes. So our primary objective is that unlike previous studies that only focus on the age group like 80 to 40 years old, we have focused on all the age groups. Then we have implemented an intelligent preprocessing pipeline that handle real world noise, and we have used segmentation model to isolate the lesion before diagnosis. So in our review of existing research, we found that deep learning, specifically CNN, has largely replaced machine learning by the paper 2. And by paper 1, we have know that transfer learning works better uh, in skin cancer detection. So, and by third paper, uh, by fourth paper, we know that VGG60 is accurate, but training is very costly. And third paper achieve 94 accuracy. So, fourth paper also shows us that the ensemble method reduce model bias, and for sixth paper, traditional machine learning models, and for fine image details, as well as there are different research paper and literature review done on different paper, which shows that without overfitting, we can easily detect benign and malignant lesions. So, here is our proposed pipeline. It is a dual stage process. Instead of feeding raw image directly into classifier, we first pass them through pre-processing stages. So then segmentation stages. So then we can send a clean lesion to classification model. So this is our work step. First, data collection, pre-processing, augmentation, segmentation, feature extraction, classification, and output result. So for segmentation, we have used UNet, which is a digital highlighter that that can like remove the noise from the images like hair and veins. And so for after that, our pre-processed image, we will give it to our classification model. For now, we have selected efficient net, and after that, we will get the output of benign or malignant. So this is the again normalization methodology that we will resize image, then normalize it to scaling, and for noise handling, we are using segmentation model UNet. After that, it is also again model architecture. For now, we have used efficient net. After getting higher accuracy, we will use other models. Then, with this, I will conclude my project, my present. By using intelligent image preprocessing pipeline and by using segmentation, unit segmentation model, we have achieved accuracy of 78 and build a stable system capable for analyzing diverse data. We have worked on small data set and we are working on a larger data set, which is from ISEC 2019. It is a metadata set. And our future work will focus on expanding the data set to further improve accuracy for clinical use. And this is the few references. And then I would like to thank Charuset University and my guide Bhavika Patel for their support. And thank you for your time. And I'm now open to any questions you may have. Hello.
Yes, ma'am. Your presentation is very nice.
Thank you, sir.
Hello.
Yeah, thank you, sir.
Yeah, ma'am. Ma'am, have you used any activation function?
Can you repeat the
Am I
sir?
audible?
Can you repeat the question, sir? Hello. Hello. Am I audible, ma'am?
Yes, ma'am, you are audible.
Sir asked me some question, but I think there is some
Yes,
connection issue.
yes, ma'am. There might be, sir might rejoin. Meanwhile, we can move further and we can come back to the question at the end.
Okay. Is it okay if I leave?
Yes, is it okay? We can move further and we can call out you at the end of the session for question answer round.
Okay.
Thank you, ma'am. So moving forward, we have next paper by author Meera Joseph. The title of the paper is The Use of Artificial Intelligence for Transforming E-Governance in Kerala.
Good morning, everyone. Can you hear me?
Uh, yes, ma'am. You're audible.
Okay. Um, so today I'm presenting a paper on use of artificial intelligence for transforming e-governance in Kerala. My co-author is Natasha Madhav. She is from Emirates Independent Institutes of Education, South Africa. And I am Meera Joseph, Rosebank College Independent Institute of Education, South Africa. I'm pleased that I was given an opportunity to present this paper for this ICTCS in Jaipur. So Kerala is the first Indian state to provide all government services digitally. And this was a motivation to study e-governance in Kerala in particular. So the ICT initiatives, say for example, we have Akshaya, ICT initiatives for citizen service delivery and participation is quite popular in Kerala, and there's actually limited information on the use of AI in particular for e-governance. So what we have done is we have used a systematic literature review, in particular PRISMA, preferred reporting items for systematic reviews and meta-analysis. The guidelines were followed for systematic literature review to explore the AI use in transforming e-governance in Kerala. Then we used bibliometric analysis, that's a research methodology, and visualization was done using WAS Viewer. We used Dimensions database as well. So the research question remains, how can AI transform e-governance in Kerala? So based on this literature review, first we looked at the government and emerging technology. So there's a big shift in incorporating AI technology for crime, big data repository, security, and healthcare. So ICT in particular is instrumental in digitizing administration processes, for example, improving service delivery and enhancing interaction between government. Sorry, you can still see my screen, right?
Yes, ma'am. Please continue.
Okay, so the next literature review that we have done is ICT for e-governance in Kerala in particular. So ICT enabler of Kerala's governance transformation. It was an enabler for governance transformation, and it provided the infrastructure necessary to enhance transparency, administrative efficiency, and citizen engagement. So ICT interventions, digitizing routine administrative procedures streamlining service delivery and enhancing communication between panchayat institutions and citizens. So the early programs demonstrated the transformative potential of technology, but challenges such as infrastructure limitation, training needs, and institutional capacity constraints were there. So Kerala experience is actually a critical lesson for other regions. So digital technologies must be complemented by robust governance frameworks, human resource development, and ethical oversight to achieve inclusive and sustainable outcomes. AI for e-governance in particular, Kerala has achieved advanced from a foundational ICT initiative to sophisticated models in incorporating algorithmic governance and smart policing. So for governance or e-governance and policing in Kerala, the assimilation of big data, AI, ICT, and algorithmic infrastructure is proposed for the for modernization of Kerala. So we chose Kerala as one of the case studies to study for this particular research. So algorithmic governance in Kerala leverages data analytics to optimize administration decision making and to analyze and forecast the outcomes. So smart policing models further enhance law enforcement while maintaining transparency and accountability. So we have initiatives like Akshaya. So we have Kerala State IT Mission, the Akshaya Kendras, for instance, which was implemented in the e-literacy and product launch phase, which has potential for future AI adoption. So the reliance on technology requires institutional disposition and capacity, cohesive policies, and a governance to effectively leverage ICT and AI. So, say for example, data and other experts discuss the challenges and risks of implementing IT so AI in particular, not ICT alone, AI in particular in public sector. So there are data privacy issues and algorithmic bias. So generative AI for citizen engagement is presented in other papers for disease management, especially during the COVID times or pandemic season. Then AI adoption to reshape geopolitics is recommended in Vijay Kumar's paper. So this is how typically the e-Kendras for Akshaya looks like. This is in particular from Kasaragod in Kerala. So we look at Prisma, how we use Prisma to Prisma steps to follow this systematic literature review. So first we identified the papers, records were identified to dimension database, records after applying filters, then we did the screening, records were exported for analysis, records were excluded, then we had eligibility criteria. It was visualized using WOS viewer, then themes and clusters were identified, and final articles contributing to thematic analysis were identified. So we have the figure that I just explained to you now. We have a sample search string that is ICT or AI and e-governance and Kerala. Then the databases searched included Scopus, Web of Science, PubMed, Google Scholar, right? The exclusion criteria were articles unrelated to e-governance, the gray literature and conference abstracts without full text. So the study focuses on ICT and AI in e-governance in Kerala. The articles from Dimensions database were used, which in particular discuss e-governance in Kerala. So this is that figure that we use for Prisma, the steps that we followed literally. So then we have, from here, we have the AI for governance. We have a few papers from George, from Varghese, from Beena, Yun, and Vijay Kumar in particular, which were quite appropriate for qualitative synthesis. So George's one actually shows a case study for Kerala's local governance model. So that's decentralized governance, improved participation and service delivery. Varghese's paper actually focuses on a conceptual analysis, right? And Bina's paper focuses on statistical analysis of e-governance outcomes. Then Yoon's paper, exploratory study, generative AI for governance. So this is generative AI for citizen engagement and policy understanding. Then we have Vijay Kumar's paper, which was basically the AI adoption to reshape geopolitics, economy, and governance globally. So this table in particular illustrates how foundational local governance, ICT-driven interventions, and emerging AI applications collectively contribute to enhanced transparency, accountability, and citizen-centric administration. So then we have methodology. We use the bibliometric analysis. So bibliometric and research methodology to present the current state of intellectual structure and emerging trends within this research topic. So this is the methodology that we used. So the guideline for visualizing is presented in Aruda's paper. And a figure, next slide will show a figure which illustrates the steps for using bibliometric analysis. So there are four
Sorry
phases.
to interrupt, ma'am. This is the gentle reminder for the 10 minutes time limit.
Yeah. So how many more minutes do I have? Sorry.
Ma'am, you have 1 to 2 minutes to conclude the presentation.
Okay, sure. So the methodology that we have is phase 1, phase 2, phase 3, phase 4. So this is the phases that we talk about. We have different visualization. Let me go through the visualization. So first is network visualization, where we have the edges which indicate the interaction. The co-occurrences or collaborations, a central node play a significant role in linking different parts of the network. So we have broad clusters like technology, data, framework, India, and analysis in the network visualization. Then we have overlay visualization. We have blue shades, which refer to topics like government, COVID, time, focusing on issues. The green shades refer towards technology, data, access model, etc. And yellow shades refers to term, integration, framework, sustainability, and policymaker. Then we have density visualization, which have lighter areas which represent less connected and less active regions, and peripheral area, the yellow area, we see terms like climate change, health, innovation, the solution. So these are things that pick up from that WAS viewer when we did the visualization. So we came up with 4 themes. So thematic analysis based on systematic literature review. The first one was ICT and e-governance in Kerala. So we have Panchayat institutions, skilled personnel, required technical infrastructure, and a procedural framework, etc. Then we have another point that we need to note, AI in e-governance to produce service delivery, operational efficiency, and administrative workflow. So in Bina's paper, for instance, we have ICT-driven interventions in Kerala, which significantly enhanced administrative efficiency, service delivery, and citizen satisfaction. So Kerala's e-governance trajectory illustrates a successful model of integrating ICT and AI to strengthen governance outcomes. Then we have AI for data-driven decision making. So this is the next theme that came up. We see from overlay visualization, we had terms like technology, data, access, model, artificial intelligence, etc. So the role of data-driven decision making or data-driven artificial intelligence in COVID-19 management was quite popular. It is presented in Pillai's paper. Then we have AI for monitoring and compliance, for instance. So that's the last one. We have one paper by Prasad and Reggie. So national policies promoting digital democracy and cloud-enabled governance have reinforced Kerala's technological progress, ensuring digital initiatives which are aligned with broader government modernization objectives. So yellow shades in the overlay visualization refers to terms like integration, framework, sustainability, policymaker insights, techniques, reflecting in
Ma'am, you're not audible.
Hello.
Sorry, can you hear me? I
Hello.
would like to conclude with this.
Yes, ma'am, please.
Sure. So these are the ones that we would like to conclude with this. With the paper, we have Akshaya, we have Kerala Fiber Optical Network, KFON. Then we have the KAI, Kerala Artificial Intelligence, which was inaugurated recently, only in 2025. That's why we don't have much data on that. To accelerate the adoption of AI for better governance, public service delivery, and an innovation ecosystem. Right. But the WOS viewer visualization actually shows us what are the terms that we're picking up. So density map, the density visualization in particular shows terms like data, technology, innovation, AI, which are closely linked groups. Then we have IoT picking up, machine learning picking up, that shows us an emerging trend in e-government initiative. Thank you, everyone. Any questions?
Yes, ma'am. Actually, your topic is very interesting as well as your presentation is very nice. So I have simple doubt. Can we replace AI with generative AI?
I'm sure you
Hello?
can. Yes, I'm sure you can.
Okay.
Definitely. Yes.
Yeah, okay. Thank you.
Mr. Dhaneshwar Nathawahal, are you there? I believe he has not joined. Now, I sincerely thank all our authors for their excellent presentations and contributions in this session, and all of our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTCS 2025. I also thank our session chair, Professor Pankaj Chandri, for his valuable time. A token of appreciation to the chair on behalf of team ICTCS 2025 and Global Knowledge Research Foundation and partners. Thank you all for your valuable presence and thank you, sir. If you would like to
Yeah,
share.
sure, ma'am. Yeah, first of all, I would like to say thanks to GR Foundations and team for giving me this wonderful opportunity to work as a session chair. As usual, your teamwork is proper. You are very punctual, and definitely you are doing great task. Uh, I enjoyed all presented paper, and definitely I learned many more things from each and every presenter, and I hope each and every presenter also learn something from each and every presented paper. Once again, I will say thank you to GR Foundation and team. Again, thank you to Meghna madam, and special thank to Richa madam also. Yeah, thank you, ma'am.
Thank you, sir.
Thank you.
Now, I kindly request you all to switch on the camera for a quick snapshot of the virtual conference. Just give me a minute.
Done. Thank you so much, everyone. Thank you so much, Meghna. Thank you so much, Pankaj sir.
Yeah, ma'am.
Thank you.
Thank you.